Okay, guys. Then welcome for joining. Welcome to our very first community call in 2024. Thank you guys for joining. It's still quite early in Europe time zones, but let's get this started. So for today, we structure the community call a little bit different than usual. My plan is to just go through the major highlights of the last months of last year, what we achieved, what we worked on. And then I'm going to switch to explain you a little bit more about ETHDA, our new data availability solution for the Ethereum community. And you are free to ask me any questions afterwards, because we noticed obviously there are a lot of questions, maybe a little bit of confusion. I'm here today to clear this up, to help you guys with all questions you have, and try to answer it to my best knowledge. I'm sitting on the business development side. I'm very familiar with the technical concepts of ETHDA, data availability, and so on. Maybe if your questions are too technical, then I might get back to that later in the chat after consulting with the tech team. But I think I can answer most of your questions. Cool. So let's look what we did in last month. So on the ecosystem side, we actually had some really big announcements. One, for example, was our collaboration with Movement Labs. Movement Labs is like Aptos and like Sui, another layer 1 blockchain based on the Move language. As most of you already know, we already deployed our smart contracts to the Aptos ecosystem in the Move language. And by forging this partnership with Movement Labs, we are going to explore more within this developer ecosystem, and also had, for example, a Twitter space where I joined to talk about, it says DeFi, but it wasn't really about DeFi. It was more about very general topics. But I had a chance to talk more about Crust, what possibilities developers of the Movement ecosystem have to collaborate with us and to actually leverage decentralized storage for their dApp and their use cases. Then the next big announcement we made was our partnership with Algorand. Algorand, a very popular layer 1 blockchain, mostly focusing on institutional use cases. But like every kind of use case, storage is an essential part of providing decentralized services to users. And we did that by providing all of our storage resources to the Algorand ecosystem. This means Algorand community users and developers now have access to Crust storage services via different channels. First of all, they can interact with our services via the smart contract we natively deployed to the Algorand ecosystem. Then their users will have access to Crust files, our end user targeted dApp, which is like a Dropbox application. So Algorand users can log in with their wallet right from the Algorand network to utilize this product as well. And last but not least, we will bring our Web3 storage bucket NFTs to Algorand as well. So next to deploying it to Arbitrum, to Ethereum mainnet, now Algorand will be able to enjoy those resources on their ecosystem as well. So we're looking really forward to this collaboration. There are still a lot of things to come to promote this partnership, to get adoption among Algorand builders for Crust. And keep your eyes out. There will be many activities in the future, and maybe you will be able to join a few of them. Then you probably saw the announcement by Optimism. Optimism gave us a shout out on Twitter about our integration, about our EVM storage protocol that natively provides the services to the entire OP ecosystem. And for all of you eager ones who checked the retrospective grants from the third cycle, you will see that Crust actually received a grant worth almost 75,000 OP tokens. And this will be also announced publicly during our, or on Twitter or on other channels by ourselves. So you heard it here first, unless you did your own research so far this morning or last night, because then it was published. And we're also going to use those OP tokens, obviously, to foster growth for Crust, especially within the OP ecosystem, within Ethereum. We intend to do that, for example, by different things, like incentivizing builders to actually use Crust, where we could provide free storage resources for OP builders, and so on. So many new opportunities for us to actually contribute to our growth. Yeah, and that's so far from our partnership side from December. You've seen a lot of things happening, but all of this is probably considerably minor compared to what we also announced during December, which is ETHDA, our data availability solution for scaling Ethereum through native L2 data availability. And also when you check on CoinGecko, then you can see that our token already was listed among other data availability solutions, which are quite popular, like Celestia or like NIA, who also recently announced the development of a data availability solution. So I want to take the next 5 minutes maybe, or 10 minutes, depending on how long it takes, to give you a quick intro about what is data availability, why do we need it, how does Crust get involved, what makes our solution special and stand out compared to other existing DA networks, and how does all of this relate to Crust and our vision. So first of all, I want to say that data availability is probably just another way of scaling initially monolithic blockchains. So we have different layers and functions of a blockchain. We have the settlement, we have the execution, we have the consensus, and we have the data availability layer. And in Ethereum layer 1, basically everything was handled on one chain. When Ethereum decided to scale via rollups and layer 2 solutions, then this basically was the first step towards modularization, which means by having layer 2s, they removed the execution layer from Ethereum directly and put it on these layer 2s to remove the workload on Ethereum. And by that, we were able to scale Ethereum via layer 2s. But there are more layers, like already mentioned. For example, the data availability layer, which also currently still mostly is provided by Ethereum layer 1, but which is a big bottleneck when it's about throughput and also costs on layer 2s. Because all transactions that are happening on layer 2s need to be batched and need to be sequenced to layer 1, where all transaction data will be stored and where it will be kept available for fraud proofing, to be used in other applications, for full sync of new nodes that are joining, and many more reasons. And only when this data is available, then the transaction actually can be settled. Now, data availability chains basically say, okay, next to removing the executional workload from Ethereum layer 1, we also can remove the data availability and storage load from Ethereum by actually storing all this transaction data on another chain, and by publishing the proof that the data is actually available to Ethereum, which is a way lower workload, requires way lower throughput, and so on. So next to this kind of modularization of layer 1 Ethereum, we also see other developments. to reduce the workload based on data availability. For example, Ethereum currently is introducing proto-dank sharding and in the future dank sharding. They do that with the EIP proposal 4844. And this proposal, for example, introduces block carrying transaction, which is a new transaction format that will be introduced, which only is responsible for storing this transaction data from layer 2s in so-called blobs. Those blobs are basically data containers containing this transaction data, but those blobs also can be utilized to store any other kind of data. For example, what we do with Crust Network at the moment, files, user files, hosting decentralized applications, and so on. And that's where Crust Network actually saw an opportunity to tackle the problem by building a layer 2 data availability solution that can be used by different layer 2s, by roll-ups, layer 3s, app chains, everything that's basically built on top of layer 1, Ethereum, to provide a data availability layer to store all kind of transactional data in form of blobs. And ETHDA maintains this data on their nodes. Later on, we will have a decentralized network of sequencer nodes, and they will maintain the data guaranteed via data availability sampling. And we also can utilize this kind of architecture to store any kind of other data for dApps like NFT metadata, social file data, gamified data, and so on. And here's an overview that basically shows how ETHDA is supposed to work. So ETHDA is shown here, with the bigger thing in the middle. And on the right-hand side, we see different use cases. The first use case, I start at the bottom, would be for layer 2s, layer 3s, app chains, Validium chains, and so on, who basically store and upload their transaction data via blobs to our network, ETHDA. And ETHDA basically generates proofs that the data is available and sends those validity proofs to Ethereum layer 1. And after Ethereum layer 1 basically receives the proofs that the data has been published and the data is available, only after then the transactions can be settled on Ethereum itself. On the top, we see other use cases. That's what I was talking about, utilizing those new kind of blob assets as data containers, not just store data, but to also store any other kind of data. Because those blob is just like a data container, and you basically can customize this to utilize those data containers for any kind of other data. And here, this slide shows how we differentiate from existing solutions. So one, probably the biggest differentiator is that ETHDA is becoming the most native data availability solution for Ethereum developers. This is for multiple reasons. For example, we personally deploy our ETHDA chain on top of the Ethereum stack itself by choosing to deploy a CK layer 2. We also gonna utilize Ethereum as a native token for gas fees within the network and to store the block transaction. Another big differentiator is that we retain all of this data permanently. So all data will be maintained permanently on ETHDA in the same way the transaction data is currently be maintained permanently on Ethereum layer 1 as well. But with the new Ethereum proposal, this data won't be stored permanently anymore. In fact, it will be purged and deleted after 3 to 4 weeks. And the data has to be archived via third-party solutions. And we as Crust and as ETHDA decided to maintain this data permanently, which provides us with another differentiator compared to other solutions like Celestia, Veil, Eigenlayer, etc., who decide not to store the data permanently for, probably cost reasons and so on. Another big differentiator is that we actually utilize those block transactions for decentralized storage applications, which others don't do either. And we also going to use data availability sampling, which is proposed by Ethereum itself. Our mechanism is very comparable to the ones that Ethereum intends to implement at some point in the future, to again totally be aligned with Ethereum scaling roadmap and vision. And also this will lead to very low costs for layer 2s, because they can save money on publishing data to Ethereum. I think I recently saw a nice Twitter post that said that just in 2023, the top 8 layer 2 solutions spent around $250 million to publish data to Ethereum layer 1. And 90% of those costs actually were related to data availability. Because it's super expensive to actually store and maintain all this transaction data on Ethereum layer 1. So by utilizing this modular DA solution and storing the data not directly on Ethereum, but by storing it on some modular DA chain, layer 2's app chains actually can reduce their transaction costs by up to 100x. And can increase the throughput by a lot. So that's a quick overview about ETH and our achievements of last month. If you have any questions, feel free to turn your mic on or to ask it in the chat. For anybody else, please mute yourself, as you can hear some music in the background. Are there any questions? I'm checking the chat as well, but so far I couldn't see anything.
Hello, Lute. Good morning.
Good morning. Do you have a question?
Yes.
Sure, go ahead.
Okay, it's not really directly related or technically to what you've discussed, but I was wondering, is that a PowerPoint that you used for the presentation? Can it be made available so that people can actually go through it, and afterwards questions could come after further research?
Yeah, I recorded this space, and usually we are putting it on YouTube. So you will be able to rewatch it, to have another look at the slides. But in the near future, we're also going to publish more and more documentation about ETH to provide more info to our community. And actually, I think that's also some alpha for you guys. Next week, we should see the very first launch of the ETH testnet, and also with some decentralized applications, which we would encourage our community to play around with and to try out. So you definitely will hear more about ETH in the near future and over the next year for sure. But if you want to learn more about what I just said, then feel free to check afterwards in YouTube, where we will upload this space.
All right, thank you.
Okay, I have a question here in our Telegram chat. What are the cons comparing Crust ETH to Near or Celestia? I think this slide here shows it the best. The biggest differentiator probably is that ETH is directly built on top of Ethereum as layer 2. When we look at competitive solutions like Celestia, then Celestia is not built on the Ethereum tech stack. Celestia is actually built on Cosmos. In the same way, Avail is not built on Ethereum, but it's built on Substrate. And this imposes obviously other requirements on builders, because those ecosystems obviously have to communicate with each other. Also, they use another token, which also imposes another barrier for developers, for users to first have to acquire the token, maybe have to bridge it first, and so on. Modularity in general is a great tool for scaling.
I don't really know that. I don't really know.
But the hidden costs of modularity are the additional complexity being imposed on builders. And our aim is to reduce this complexity introduced by modularity as far as possible. And this only is possible by providing the most intuitive, most native solution for Ethereum. And we do that by utilizing the Ethereum tech stack, by leveraging the security layer provided via Ethereum. And yeah, to have like a seamless interface for all Ethereum developers that can stay within the ecosystem. Basically a solution built on top of Ethereum for Ethereum community, and Celestia Avail are not positioned in that way. And next to that, obviously, we have on the product level other features which differentiate us from Avail, Celestia Eigenlayer, etc., which is the data retention part, where we retain the data permanently instead of just temporary for a couple of weeks. And the fact that we actually will contribute a lot of innovations around those block carrying transactions, which also makes us or allows us to use those blobs for these decentralized storage use cases. I hope this answered your question. Okay, what measure did the team put to ensure Crust networks longevity? Well, by having an additional DA chain, this obviously will create another stream of revenue for Crust as ecosystem and for Crust as project. For example, we will generate gas fees on our network. Later on, we will have an economy of decentralized sequencers. All of this will create specific revenue streams in Ethereum, because if we charge Ethereum as gas fees, then this is also what we basically can generate revenue with, which means it's like a non-inflational revenue stream, because it's not in CRU, it's in Ethereum, by paying customers, by paying users, generating traffic on ETHDA. And this obviously can flow back to Crust as a project to maybe incentivize stakers later on to stake on decentralized sequencers for any possible kind of activities we are doing in the future. Okay, another question. How does ETHDA handle the permanent storage of sharded blobs? Yeah, that's already a very good question. It's already a little bit technical, but I try to answer it the best I can. So those blobs will be stored permanently directly on our nodes. We probably will have within our network of nodes different roles that will be assigned to nodes, if they are storage node, if they are sequencer nodes, and so on. And the data will be stored in those nodes, and they will be guaranteed by our data availability sampling, which basically is like a randomized protocol that checks and verifies the availability of the data via different attestations and so on. And we actually gonna use some of our expertise we already gained via our permanent storage features in Crust network, especially when it comes about the incentivization mechanism. And those permanent stored blobs will be stored via we call it blob weave. Blob weave is just like an almost comparable like the block weave what Arweave offers. We just do it for blobs. And via this blob weave, we can retrieve the data also via different gateways, let's say just comparable to Crust. and keep it always available and always retrievable. In your roadmap for our DAO. What specific do you mean by that? So far, we have the CRU token, which isn't a traditional DAO token. It's more like a utility token for our network, but it definitely has some DAO components to it, since you can use it in different governance mechanisms, votings, and so on. But yeah, we don't have a traditional DAO token in that sense. Okay, I see nobody else typing. So I guess that's it. Let's call it a day. If there should be any other questions, feel free to tag me in the chat, Loot Clay, and I'm happy to get back to you. All right, guys. Then thanks for your attention, and enjoy your weekend, and see you latest next month. Bye-bye.